Welcome students. In this B.Sc. Part 2 class, you are going to study the chemistry practical. The practical is of 2 days, which includes the practicals of inorganic chemistry, the practicals of organic chemistry, and the practicals of physical chemistry. Now I will deal with the practicals of organic chemistry. Some practicals I am going to teach the practicals of the variety, organic preparation and organic estimations. Therefore, practical of organic estimation, and here we are going to see the estimation of ester ethyl benzoate, that is the reaction of hydrolysis of ester giving potassium salt of acid and alcohol, that is ester on hydrolysis gives acid plus alcohol, and we can estimate the amount of ester present in the solution. This is the aim, to estimate the amount of ethyl benzoate in the given solution of ethyl benzoate. Yes, you have supplied the solution of ethyl benzoate and you have to determine the amount of ethyl benzoate present in the solution given to you. What are the apparatus? As usual, burette, pipette, conical flask and water condensation. And this estimation is volumetric estimation, that is titration. Chemicals are 1 normal potassium hydroxide solution KOH, then 0.1 normal hydrochloric acid and phenolphthalein as an indicator. What is the principle? Yes, this is the principle. And ester is hydrolyzed by boiling under reflux with excess of alkali. What is the reflux? That is boiling in the water bath using water condenser. And after the hydrolysis is complete, the excess amount of alkali, that is it is retained in the solution, is determined by titrating it against standard solution of acid, that is a 0.1 normal hydrochloric acid. The reaction is, this is a ethyl benzoate ester, hydrolysis in presence of alkali potassium hydroxide, formation of potassium salt of benzoic acid and ethanol, that is alcohol, is obtained. Therefore, some amount of this KOH is consumed with this reaction and the excess of KOH which is remain is back titrated against hydrochloric acid from the burette, and this is the reaction of acid alkali giving salt plus water, and this excess amount is determined by which we can determine the used amount, and from that the percentage or the quantity of the ester can be determined. The procedure involves, the first point is, as you have given the ethyl benzoate solution in the flask, and to that flask add 25 cubic centimeter of approximately 1 normal KOH solution by burette. Okay. Therefore, you have to add the KOH which will react with the ester solution present already in the flask. Okay, this is the flask. This is the potassium hydroxide. The solution is prepared. This is a potassium hydroxide solution. You have to use this solution, fill the burette and take the 25 ml of this solution in the flask and add 2 porcelain pieces, that is, these are boiling chips, to avoid the bumping. Okay, and therefore you have to add, because we are going to boil the solution in water bath using water condenser. Then fix a water condenser to the flask and heat for about 90 minutes on boiling water bath. You have to heat the total reaction mixture on water bath for 90 minutes. Okay, this is the condenser, water condenser. This is the inlet of water, while this is the outlet for water. This condenser is fixed to this flask. Okay, I will show the diagram. Okay, here the flask is here, the solution is kept. This is the condenser, water inlet, water outlet, and thus this is the water bath where water is present and heating is with a burner. Okay, and therefore heat this for 90 minutes. As we have added the KOH solution, it will react with the ester to hydrolyze it into acid and alcohol. Therefore, some amount of ester, some amount of alkali will be consumed, and the remaining amount will as it is. Now, ester is hydrolyzed to corresponding acid and alcohol. After heating is complete, cool the flask, that is the reaction mixture, first at room temperature and then using tap water, that is under running tap water, and then transfer the contents to 100 cc measuring flask, that is a dilution flask for the dilution. This is the dilution is done using distilled water, and therefore dilute the reaction mixture 200 cc exactly with distilled water. The dilution is shown in this. This is the volumetric flask, or this is a measuring flask of 100 cc, and the mark is there. Up to the mark you have to dilute. I will show the total volume with this is the diluted. Okay, as we have shown the colored to identify the how much quantity is, that is where is the mark. Okay, where is the mark. Then titration. This is the back titration, that is a titration of the reaction mixture with standard acid solution. We are using 0.1 normal hydrochloric acid. Okay, the first step in the back titration is pipette out 25 ml of this diluted solution, that is reaction mixture, and titrate it against 0.1 normal hydrochloric acid from the burette using phenolphthalein as an indicator. Now, in the burette we have filled acid, and in the titration flask we have taken the reaction mixture containing alkali, and therefore when we add the drops of phenolphthalein indicator, then the pink color will be obtained to the solution. Okay, the end point is the color changes from pink to colorless, as phenolphthalein has pink color in alkali, while after neutralization of alkali the color will be changed due to the excess of acid drop in the reaction mixture, and it will become colorless, and thus end point is determined. Okay. Take 3 readings and note the constant burette reading. Here constant burette reading out of 3, which 2 readings are constant? Note that constant reading as a BML. Here remember students, mean is not determined. Here constant burette reading is determined, and thus enter your results in the tabular form. Okay. Observations. The first one is solution in burette, 0.1 normal hydrochloric acid. That is, fill the burette taking usual precautions. No air bubble should be in the burette, and burette should be filled up to the 0 mark. Okay. Then in the titration class, you have pipette around 25 cc of diluted reaction mixture, that is the heating solution which is diluted, out of which you have taken 25 cc for the titration. The indicator is phenolphthalein, and the color change is from pink to colorless, because phenolphthalein has pink color in the alkali as told, and changes to colorless. Observation table. Here observations, final level burette reading, the final level of the first reading. Note down here initial level, it may be 0, and take the difference. Thus take 3 readings, and out of these 3, which those are constant, mention it as a constant burette reading as a B cubic centimeter. Okay. Next is blank titration reading. Here the KOH is directly reacted with acid, and the procedure includes dilute 25 cc of given 1 normal potassium hydroxide solution, that is alkali, to 100 cc exactly with distilled water. The dilution is 200 cc. Then titrate 25 cc of this diluted solution against 0.1 normal hydrochloric acid solution from the burette using phenolphthalein as an indicator. This is the blank titration, because here the sample is not reacted with the alkali, while in the back titration the sample is first reacted with the alkali and it is then titrated, and therefore it is known as a back titration, where this titration is known as a blank titration. There is no sample. Okay. In end point is same, color changes from pink to colorless. Take 3 readings and note down the constant burette reading as AML. Enter the reading in the tabular form. Observation table. First observations. The first one is solution in burette. Of course, 0.1 normal hydrochloric acid. Solution in titration plus 25 cc of diluted alkali solution, that is a KOH solution that you have diluted. The indicator is phenolphthalein, and end point is color changes from pink to colorless, because phenolphthalein has pink color in the alkali, as alkali is present in the titration plus. Okay, observation table. This is the observation table. Okay, here observation, note down first observation, final level, initial level difference. This is the second reading and third reading, and out of these three, which two are constant? Note it as a constant reading ACC, that is cubic centimeter. Thus, there are two varieties of titration. The first one was seen, that was a back titration, that is the titration of the reaction mixture with acid, while the second one was a titration of a plain alkali with acid. Now, here I will show you have taken the diluted solution for titration using pipette in the titration flask. Yes, this is the indicator, this is the phenolphthalein indicator. You have taken drops of phenolphthalein indicator in this. Before dropping the indicator, this is the colorless. As the phenolphthalein is added to this alkali, it changes to pink. This is the pink color. Now you have to disappear this pink color by addition of acid from the burette, and therefore carry out the titration till the color changes from pink to colorless. That is, the color is going due to the addition of acid from the burette. And as the acid is added to the alkali, the first neutralization of alkali takes place, and the further drop of the acid changes the color of the phenolphthalein to colorless, because in acidic medium it has a no color, while in alkali it has a pink color, and therefore thus end point is reached, that is the required amount of acid is added for the neutralization of alkali. Then calculations we are going to see one by one. The amount of potassium hydroxide consumed by 25 cc of a diluted reaction mixture in terms of 0.1 normal SCl. Reaction mixture 25 ml. How much quantity of KOH used? A minus B, because A is a total while B is excess, and therefore when we take the sum of A minus B, the used KOH is determined, that is the amount of KOH consumed by our ester solution. The amount of KOH consumed by 100 ml total volume of the diluted solution, we have pipette out 25 ml. Total volume is 100 ml, and therefore for total ml, total volume for 25, this is A minus B. For 100, 4 times A minus, because it is a 4 times solution, and therefore it is a capital XCC. From the reaction we get 1 gram equivalent of alkali KOH is equal to 1 gram equivalent of acid hydrochloric, which is equal to 1 mole of ester ethyl benzoate. What is 1 gram equivalent? That is 1000 cc of 1 normal KOH is equivalent to 1 mole of ester. That is 1000 cc of 1 normal HCl is equal to 1 mole of ester, means 150 grams of the molecule. That is 1 ml instead of 1000 cc, 1 cc of 0.1 normal gives the value 0.015 gram of ethyl benzoate. Therefore, this value is decreased to this. And for x cc of our 0.1 normal HCl will be 0.015 into x divided by 1. This is this one. Okay, that is equal to y grams of ethyl benzoate. Results. Students, enter your results. The number 1 is the volume of 0.1 normal hydrochloric acid equivalent to KOH consumed, that is used during the hydrolysis of the ester ethyl benzoate in the given solution, which is equal to A minus B, which is equal to X, and which is equal to dash CMQ. And the second result is the quantity of ester ethyl benzoate in the given solution, that is equal to y gram, that is equal to dash gram, that is equal to dash kilograms. Okay. Now students, write down this experiment in the journal with the help of practical handbook and this video. Now as journals are not with you, you have to write the practicals on Polsky paper and submit the result with your name and roll number on mail of our chemistry department. And for writing the journal purpose, you have required the blank titration and back titration, and therefore take A equal to 24.9 cubic centimeter, that is for blank titration, the constant period reading I am giving, and for back titration it is 18.1 cubic centimeter. This is the CBR, and therefore mention the other readings. Two readings must be constant. Now the hints for journal writing, that is on the Polsky paper. On the right hand side, write down aim, apparatus, chemicals, then principle, then procedure of the experiment, and finally results. While on the left hand side, write down the reaction, observations like solution in burette, solution by pipette, indicator, that is pipette being the titration flask, then indicator used, what is the end point, then observation table, and finally calculations. And therefore complete the experiment as it is completed by the teachers and submit your record as the presentee of your practical. Okay. Thank you.